Hi guys and welcome to the Quinn podcast. Here we give you a look through the eyes of the most successful athletes, entertainers, entrepreneurs and influencers on this planet. Be sure to check out all of the content at quinnpodcast.com. Enjoy the episode. So you started developing Mimio in college, right?
In grad school, yeah.
In grad school. Okay, take me through that. What was sort of life like back then and coming up with a product like this?
Yeah, for sure. So basically, when I got out of college, did my BS in biochemistry at Loyola Marymount University down in LA. Didn't really know what I wanted to do with that degree, right? Like a lot of college kids, just, knew that it wanted to be something in research, but wasn't really sure what I was passionate about. So I took an immunology fellowship at Stanford, where I just started pouring through all the research that I could get my hands on, trying to find out, what excited me, and eventually came across healthy aging research and longevity research, which I thought was super duper fascinating, right? Because it used to be like myth and legend, right? Like Ponce de Leon and the Fountain of Youth. But now it's like very, very active area of scientific study. And when you're in that space, eventually you come across fasting, because fasting is one of the only ways that we know about to reliably extend lifespan in animal models. And then when you dive even further into the research there, it's also like really, really powerful for enhancing health span. So helping to kind of treat, prevent, or delay most major diseases. And it does all of that without actually adding anything into the body, right? So it's not like this superfood or this wonder drug that's causing all of this to happen, but somehow fasting is triggering this, dormant, innate longevity bio program that we already have inside of us, but just isn't ordinarily turned on. And so when that clicked for me, I actually got mad about it. Because I was like, oh, great. So my body knows how to live to be 120 years old and in perfect health, but it's just not doing it. So that was what really, kind of catapulted me into wanting to figure out, all right, what is happening in the human body during a fast that could be causing all of these great, cellular health and longevity effects? And is there a way that we can recreate it? So that's really what I went into my graduate program wanting to research and wanting to learn more about it. And eventually the thing that became Mimio.
For sure. What is it about fasting though? Like I said, I know basically nothing about this.
Sure.
Why does it work?
Yeah, it's a really interesting story about why fasting works, but like at a very high level, you can kind of think about it from an evolutionary point of view, right? So let's say we're in an environment that has a lot of food around, a lot of nutrients, we're constantly in a fed state. That's basically telling our body, all right, great, this environment is really good for producing children, right? So we're not really gonna take care of this generation all that much. We're just gonna focus on, getting to the next generation. So our cells are gonna like kind of run dirty, right? They have plenty of nutrients around, so they're gonna make all the proteins that they want. They're gonna translate all the DNA that they want. They're gonna replicate as many cells as they want. They're not going to be all that concerned about like damage that happens or, dysfunctional proteins or making too much of something, because they have all those nutrients. So if something goes wrong, it's fine. We can just make a new cell, right? So that is kind of what the ordinary feeding response that our cells get is. In a fasted state, all of that really gets flipped on its head. That is an evolutionary signal to our bodies that the environment around us would not be good for raising kids, right? Because if we don't even have enough nutrients for ourselves, the likelihood of having enough nutrients for a kid on top of that is really low. So instead of focusing on the next generation, our body starts focusing on the current generation. So it's like, all right, we need to help get this generation and make them survive as long as possible so they can find a new environment that has a lot of food and then can get them to the next stage of progeny, right? So what happens at the cellular level there is that the cells are like, well, crap, we don't have enough nutrients to do all the things that we want to do. And we don't have enough nutrients to be able to create new cells if something goes wrong. So it turns on a lot of these maintenance, repair, recycling, metabolic efficiency pathways within cells that essentially helps to enhance their protection from stress, reduce damage, especially metabolic mitochondrial damage like free radicals and reactive oxygen species. It helps to enhance autophagy, which is essentially our cellular cleanup and recycling process. So that takes, damaged and dysfunctional proteins and organelles and turns them into shiny new parts that are actually functional. So really a holistic cellular program that is trying to maintain the health of your cells as they are now, so they don't have to, replicate, nothing gets damaged, this generation can survive. So that's basically the evolutionary background of why fasting really works the way that it does. It's all about helping the current generation survive as long as possible so that we can then get to the next generation.
Right. So is it sort of about being in like a satisfied state that your body is like, okay, we can focus on the next generation, or is it more like the more you eat, the more calories you got in your system, like the faster aging goes? Or is that?
It's a bit of both for sure. There are definitely impacts of, chronic overnutrition that we have not really experienced at an evolutionary level, right? So we used to experience periods of fasting all the time throughout the course of our evolutionary history. It's only in the past, 100 years or so that we've really gotten to this point of overabundance of nutrition and overabundance of nutrients and available resources. So when we're in that, constantly overfed state, there are consequences to the body, right? You have like way higher glucose and insulin spikes than you ordinarily would, higher cholesterol levels, higher triglyceride levels. You have higher inflammatory levels from the diet that are coming into the body, and you have lower levels of maintenance, repair, and protection pathways that are being activated because by and large, your body has to get out of what's called the postprandial state, the post-eating state, and that takes around 4 to 6 hours after a meal to fully resolve. And if you're still in the postprandial state, your body is going to be focused on digestion, absorption, and metabolism. And it's going to focus all of its energy on that because it has to do that to survive. But the trade-off to that is that it's not going to be focused on maintenance, protection, and repair. So when we're in this chronic overfed state of the typical Western diet, 3 meals a day plus snacks, we're never really getting out of the postprandial state. So you don't get as much of the maintenance, protection, and repair mechanisms as you should, and then you have the increasing strain and constant strain on the metabolic system and on the inflammatory system from the overnutrition.
That's pretty crazy. With like sports and everything, I'm probably like in sort of a bulking phase, like chugging down like 4,000 to 5,000 calories, like 8
Oh yeah, sure. There you go.
So that's something to take into account.
Yeah, it's definitely a really interesting balance between the muscle health, the strength building, and then the longevity side of things, because those two things are often at odds, right? You have a lot of pathways that are involved in growth and strength, like mTOR and IGF-1 and insulin, right, that are really good for promoting muscle growth. But the problem is that growth means cellular replication, and cellular replication means that your cells are, aging faster, or they're, producing more damage. They're breaking down their telomeres. There's just a lot of different mechanisms that we know of that all of the pro-growth pathways are also, pro-aging pathways, where all of the fasting pathways and these caloric restriction pathways are associated with longevity.
Yeah, that's definitely interesting. Sort of when you get into the longevity space, like sort of common knowledge on like what's healthy and what training and everything is oftentimes like not what it is at all. Like it's so easy to overtrain, for example.
Yeah.
I figured out recently. I thought it would be harder, but it's not. That's pretty interesting. Okay, from like a fasting perspective though, like what would be sort of like perfect? Like, let's say you're just a machine and you do whatever. Like, I start doing whatever you say is the best way to do it. Like, how am I eating from now on?
Yeah. So what we see in the literature results where we get the best lifespan extension is what's called alternate day fasting. So that is basically exactly what it sounds like. You do 1 day of normal eating, 1 day of fasting, 1 day of normal eating, 1 day of fasting, and you rinse and repeat for your entire life. And what we see in animal models is that that can increase lifespan anywhere between 30 to 50%, which is pretty robust, right? And that's conserved across pretty much all species. The lifespan extension goes to different degrees depending on the species that you're looking at, but it's very, very highly conserved, again, as like an evolutionary mechanism. So that would be the thing that, as a robot, you get in, you just do the alternate day fasting. And what's really interesting is that those lifespan extension abilities don't seem to be dependent upon caloric restriction. So there is something unique about fasting where even though people are eating the same amount of calories, it all, just depending on when they eat those calories, has a really profound effect on lifespan.
So what are you looking at, like calorie-wise then? In sort of the perfect scenarios, that's pretty interesting to me. Like, let's say, whatever, what's average, like 2,500, 3,000 a day, something like that.
Mhm.
Um, like you just double it. You're eating 6,000 one day, and you're like eating nothing the next day.
Yeah, so I mean, in a perfect like isocaloric world,
Right.
calories being equal, that would be the case for sure. From a
For sure.
practical perspective, really hard to achieve, right? It's
Yeah.
like, if you are, in a bulking phase, you're eating 3,000, 4,000 calories a day, and then on one day you have to eat 8,000 calories and then zero the next day, that's going to be really difficult. So most people end up, naturally going into some form of caloric restriction when they're fasting, just because, it's really hard to get double your daily calories into like that one singular day.
Hmm. For sure. I think Brian Johnson, like, he eats like a 20% caloric deficit, like
Hmm.
at all times,
Yeah, for sure.
which are
Yeah,
sort of
I
good
mean,
enough.
and that's really well conserved in the literature as well. So, like,
Okay.
caloric restriction was one of the first things that we found that can really extend lifespan, and that is all
Interesting.
around just like chronic energy restriction. And it's usually a pretty one-to-one ratio up until the point of malnutrition. So if you're decreasing calories by 10%, you can live 10% longer. If you're by 20, then by 20% longer, 30 by
That's crazy.
30%, right? So that's a pretty well conserved mechanism that's really all around the energy restriction. But the problem with that is it becomes a much harder lifestyle over time, right? To just be constantly in a 20% caloric deficit. And that can also have some impacts on things like sarcopenia, right? Muscle wasting, that can have some impacts on things like bone loss, bone
Hmm.
density over time. So there are definitely some drawbacks that come along with caloric restriction that fasting seems to avoid, while still giving you the pro longevity effects. Because when you think about what's actually happening in the case of like alternate day fasting, right? You're never actually going more than 1 day in a caloric deficit, right? But that still ends up being half of the time of your life.
Hmm. What's the longest you've gone? Longest fast you've
Yeah.
gone?
The longest that I've gone is a 72-hour fast.
Okay.
And I was
Nice.
doing that specifically to track my own biomarkers throughout the course of a fast to kind of see, all right, where is the maximal effect? Where does the plateau happen? How long do you have to do this thing to
Mm.
get the effects that you're looking for? And what we found was that it was actually around that 36-hour mark. So things kept going up, and like increasing in benefits up until around the 48-hour mark where they kind of plateaued. But the difference between 36 and 48 was, there, but pretty small.
Hmm.
Whereas like the difference between 24 and 36 was really stark. So we
Right.
kind of decided, well, let's look at a 36-hour fast and see what's happening in the body and if there's a way that we can recreate it.
Mm, no, for sure. I did like 2 days once. I want to do a week. I'm curious to see what's gonna happen at a
Yeah,
week.
a week is a long, a long one for sure. There is a clinic out in Santa Rosa. So Mimio is based out of San Francisco. Santa Rosa is just, in the North Bay. And their whole thing is that they just do medically supervised fasts for people who just, have nowhere else to turn. They've tried everything else. They want to come, they want to do these long-term fasts to see if it can help them with whatever their condition is, whether that's obesity or type 2 diabetes or even autoimmune diseases like lupus. And what they find is that people come in, they're in this medically supervised environment, so it's very, very safe. They'll fast them for 1 week or 2 weeks at a time. And you can get really, really good symptom ablation. So what that means is you can get really good kind of suppression of a lot of symptoms, especially of autoimmune diseases, type 2 diabetes, all the metabolic conditions, from just those 1 week or 2 weeks of fasting. And those effects can continue to last for like 6 months afterwards. So you have plenty of people with lupus who are going into that facility doing, a 1 week, 2 week fast, and then getting to go back and live their lives as though they don't have their condition. So it's really, really cool.
Right, no, for sure. 2 weeks is crazy though.
Yeah, no, it is definitely crazy. Well, that's why, like anything more than a couple days of fasting, I would definitely say that, you should do it under some form of medical supervision. You should be telling your doctor about it. You should be going to one of these clinics that can really take care of you and make sure that everything is safe.
Mm-hmm. No, for sure. Okay, so you were like, okay, this is amazing, but it's not practical at all. So then R&D
Yeah.
came into place, and you came up with the solution.
Yes, exactly. So yeah, what I was doing in graduate school was looking at what happens in the body during a 36-hour fast. So we had 20 people come in, 10 men, 10 women, to avoid a gender bias and find, more universal impacts of fasting. And what we found there was that when people fast for 36 hours, there's this unique set of molecules that are produced by the body that are really only elevated during a fast. And we found that those molecules were the ones that were responsible for activating a lot of these cellular health and longevity benefits of fasting. So we basically just took those molecules, put them into a daily pill so that you can recreate fasting at the molecular level, get those same benefits, but without actually having to fast.
Take me through that. How do you sort of come up with what's going on there? Like
Sure.
the benefits, and how do you put them in a pill?
Yeah. So basically what this was we looked at the impacts of a 36-hour fast on these people's cellular functions. So we took their cells in a baseline state and in a 36-hour fasted state. And what we observed was that all of their cellular functionalities were really enhanced in a 36-hour fasted state. So their cells became more anti-inflammatory, they became more antioxidant, they became more cardioprotective, they had better metabolic function and metabolic flexibility. And that was really interesting to us, right? These were already young, healthy people, and fasting basically turned them into super people. So we wanted to know, what is the difference between one state and the other that could be causing these effects? So we did what's called plasma metabolomics, basically looking at all of the small molecule components of the blood to see what the differences were. And from there, we found that there were 300 significant differences between a baseline state and a fasting state. And so we started combing through that list of 300, looking for molecules that were bioactive. Basically, they had some kind of impact on cellular functionality, whether that was promoting autophagy or producing those anti-inflammatory effects. And we narrowed that list down to around 24 or so candidate molecules, and then started assessing them throughout these cellular functions to see what their impacts would be. And eventually, we got down to this synergistic combination of 4 of those molecules that, when we combined them together, could recreate all of these cellular health effects that we had observed during fasting. And since this was also, we're really curious about longevity, we did a lifespan extension experiment with these molecules in C. elegans in animal models, and found that we could extend their lifespan by 96% just through supplementation with these 4 fasting molecules. So what Mimio is, and what Mimio is doing, is it is taking the things that your body would naturally produce during a fast and then just giving them back to you as a supplement so that you can, activate those same cellular pathways on demand.
That's pretty crazy. That's cool. How's the response been so far?
Oh, it's been amazing for sure. Yeah, so the research itself, just to develop the actual formulation, develop technology, that took around 7 years of research in total to then, get it to the phase of it's ready to be a product. We're ready to look at it in the human body. So after that, we started doing clinical studies, and we've done 3 clinical studies so far, basically showing that when you take these molecules in combination, which is the Mimeo fasting mimetic supplement that we have, you can get these fasting-like benefits even when you're eating those same anti-inflammatory, antioxidant, cardioprotective, metabolic enhancement effects. But even during a meal. And then we've also done 2 8-week studies. One was a clinical case study at Mount Sinai. And in that study, we showed that we have very powerful impacts on metabolic markers. So we were able to improve glucose levels, insulin levels, HbA1c levels, cholesterol levels, triglyceride levels. We were able to increase testosterone by 50% in just 8 weeks. And we were able to reduce biological age by 2.5 years in just 8 weeks. So really, really cool effects there. And then we recently completed our randomized double-blind placebo-controlled study where we had equal proportion of men and women come in, do an 8-week course with Mimeo or an 8-week course with a placebo without changing their diet and lifestyle at all. And what we saw there was similar to the previous clinical study. We had improvements in glucose levels, in cholesterol levels, in reducing LDL, like bad cholesterol levels, reducing LDL particle number, which is an even better marker for cardiovascular disease risk. We reduced cellular stress levels, but then we also had these really powerful impacts on appetite suppression and hunger control. So way less distractions from cravings, much better eating only when hungry, so better hunger control there, and then improved satiety. So essentially getting fuller faster, staying fuller longer when they are eating. So basically everything that fasting should be doing for you, but just, in a simple daily pill.
For sure. Have you found anything that's like similar as far as positive effects go to what you're creating? Like you could whatever do this and it's like similar because this is those numbers are pretty crazy.
Yeah. I mean, they are really crazy numbers. I think that the benefit that we have is that we are taking this, biomimetic research approach. So what that means is, we start with human biology and try to understand how that works and then just work within that system, right? So how normal longevity science works is that you would start off in lower organisms, right? You'd start off with cells, then go to maybe C. elegans or Drosophila, the fruit flies. Then you'd go up to mice, then you'd go up to dogs, and then maybe you would go up to humans after that, right? But there's a lot of chances for what we call, non-translatability between all of those organisms, right? So something that works for cells might not work for flies, which might not work for mice, which might not work for humans. So there's a lot of avenues of disconnect that can happen. The cool thing about the biomimetic research that we're doing is that because we start by studying humans, we know that all of our findings and all of our molecules and all of our research is immediately applicable to human health. And I think that's the really unique thing about Mimeo, in that we are doing something that no one else is doing, and it's producing results that are really outsized and beneficial because we know that it comes from humans. So it's made for humans.
Mm-hmm. For sure. Are there like hypotheses you got on benefits that aren't proven yet that you're like excited about?
There are a couple that we haven't totally proven out with the full formulation itself, but have been proven out in multiple clinical studies with the ingredients themselves. So for example, one of the ingredients in Mimeo is palmitoyl ethanolamide. It's an endocannabinoid that stimulates through CB1, CB2 receptors. So has a really good clinical history of having mood promoting effects, cognition promoting effects, but then also pain relief effects as well, stimulating also through like COX-1 and 2 inhibitors. So that's kind of like the same mechanism as ibuprofen. So PEA is really interesting because it's like your body's natural CBD and your body's natural ibuprofen, and has these really like wide-ranging effects that, you know, we haven't assessed in our clinical studies yet, but have been proven out for the individual molecules themselves. So that's kind of, you know, some of the major impacts of these molecules we don't even know yet, and I think we can do much more research, especially because we've identified that the formulation itself is synergistic. So these molecules all work together to activate these complementary pathways to unlock benefits that are greater than the sum of their parts.
That's cool, man. What was it like for you as like an entrepreneur bringing this to market? You said 7 years of R&D.
Yeah, yeah. 7 years of R&D. Well, that's the thing. When we started out, I wasn't intending to be an entrepreneur, right? I was a scientist through and through, and, you know, still for the most part am. But I was just really, I had a question that I wanted an answer to. I had a hypothesis that I wanted to test. And so we went out and we did it. And I honestly thought that I was going to be spending my entire life in the lab trying to answer that question, right? And we kind of just got lucky on the first try through, right? Of like, oh, we found this thing that actually works. Like, how incredible is that? And so that's where the entrepreneur journey really came from. Is there was just a huge discovery that needed to be shared with the world and could be shared with the world. And so I kind of am very honored and humbled to be able to do that, because most scientists never get to see that happen. So much science just gets caught up in the lab. It never goes out into the world and makes a difference in people's lives. And, you know, for me to be able to go out there and actually do the thing, get the product in people's hands, you know, see the feedback, see the clinical data, see how it's working, is just really, really amazing. And the entrepreneurial journey itself has been kind of a whirlwind as well, because we spun out of UC Davis. That's where the research for Mimio was done originally, out of the Venture Catalyst program there. And then one of the first things that we applied to was the IndieBio Accelerator program, which is the largest biotech accelerator in the world, essentially the Y Combinator of biotech. And we went through that program. It was really amazing. We got to make so many great connections. We got to learn so much about the entrepreneurship process, the VC world, and ended up getting some really great pre-seed funding that allowed us to do additional research, get the product actually manufactured, and then raised a seed round after that, where we were able to launch the product, to do even more research, do more clinical studies. And that was the last time that we raised, back in 2023.
That's exciting, man.
Yeah.
What's it like going through a accelerator program like that?
Yeah, it was definitely a whole new world for me, right? I'm very glad that I had the experience, because it was basically just like a boot camp for business, for how the VC world operates, how to raise, how to story tell, how to pitch the product, right? How to really start thinking around like go-to-market strategy, everything like that, and like all things that I had no idea about before as a born and bred career scientist, right? So that was a really amazing experience. We also got to meet so many other cool people who were doing amazing things, but in their own field. So there was a lot of friends that we made that we're still in touch with now. We've got like a lot of business partnerships that we made from that experience. So incredibly beneficial to what we were doing, and really helpful for me to kind of like get everything that I needed to know in a short amount of time.
Yeah, I can imagine. That role is like super interesting to me. Like just like cramming it up in like a short amount of time, and like putting a solid business out there. That's pretty cool.
Yeah, absolutely.
No, for sure. What was like the biggest sort of skepticism in like bringing this to market? Like what was sort of the
I would say that the biggest skepticism is really the same one that we deal with all the time, which is the fact that we are a supplement. So even though we have all of this research behind us, we're coming out of a university program, we've got all these peer-reviewed scientific publications, we have all this technology that's backing us up, we have all this clinical research that we have done. We are still a supplement. And, I say supplement and people are like snake oil, right? Immediately.
Right.
And the reason that we are a supplement and not like pharma is because these are all natural molecules, right? The FDA considers all metabolites to be dietary ingredients. So that really allows us to kind of fast track the process of getting this out there into people's hands. And of course, we did all the clinical research to make sure that the formulation works, it's at the right dosage, it's safe for people, and it produces really outsized benefits. But not everybody in the supplement space does that, unfortunately. So that's kind of the challenge that we had when we were raising, and that's still the challenge that we have today when we're going out there and selling, is that there's just so much mistrust, snake oil, and misinformation in the supplement space that we have a lot of hurdles that we have to clear to get people to trust us.
What's like regulatory stuff around this? Is it easier because you're a supplement, not pharma?
Yeah, correct. So basically what you have to do in pharma to get a drug to market is go through basically 4 or 5 stages of development. There's like the phase 0 studies that are all preclinical. You're just doing the actual drug development, testing them in animal models, then going up to phase 1, phase 2, phase 3, and phase 4, which are basically just increasing levels of clinical studies. Phase 1 is more for like safety and toxicity. Phase 2 is where you actually start testing out the benefits. And then phase 3 is an even larger cohort of people. Phase 4 is an even larger cohort of people after that. And only after you go through that entire process can you get a drug to market, which is usually why it ends up taking around 10 years for a product to go from like we made it to it is now available in the market and can actually help people. On the supplement side of things, you basically only have to do up to the phase 1 study. So basically you just have to show that it is safe and non-toxic. And that's basically the bar to get what's called a new dietary ingredient filing with the FDA. What we do is we go a step beyond that into the phase 2 studies, which are, human clinical trials, of which we have done 3 at this point. So the process is easier if you want it to be, but if you want to ensure that your product actually works and does the things that you say that it does, then you really have to take it a step beyond what is required.
Right, for sure. How do you sort of, again, from a business perspective, like keep developing this? Because how long do patents go? Like 2 decades or something, right?
Yeah. Patents can last for, depending on the patent, pharma patents especially, yes, 2 decades. Other patents, something in the 10-year mark. But basically, where we go from where we are now is 2 directions. Number 1, we can continue to look through the fasting data set that we already have to identify new molecules from that list. So we had that, list of 300, right? But of that, only 2 dozen or so had some kind of clinical research on them already of having bioactivity. So what that means is that, that leaves us 275-ish other targets that people just don't know about yet. Maybe they have functions, maybe they don't have functions, but they're all upregulated during fasting. And so they all kind of fit within this, fasting bio program. So we can basically screen through those molecules to find new ones that could add additional benefits, additional synergies into the formulation, kind of, keep building out the fasting mimetic formulation that we have now to make it better and better and more complete over time. And then number 2, Just like we ran this process with fasting, we can also do it with other interesting states of the body, right? So things like exercise or sleep or meditation or cold exposure really tease out what's happening in the body during all of these places and find ways that we might be able to mimic some of those benefits as well.
Oh, that's cool. You got like like a cold tub pill. That's
Yeah,
amazing.
yeah, exactly.
Oh, that's interesting, man. That's a cool way to think about it.
Yeah, for
Yeah,
sure. Because I mean,
if you're
all of
able to,
these things,
yeah,
right? All of these benefits that happen from each of those states, you're not adding
right,
anything into the body, right? Cold exposure
right.
isn't putting anything in the body. It's just making our physiology do different things and produce different molecules that have different effects. So that's really the biomimetic approach that we're taking to research is figuring out all these beneficial processes in the human body and finding ways that we can recreate them.
What do you sort of like more from like a moral perspective? Like, what do you see as sort of the fine line between it being becoming sort of too easy to sort of
Sure.
get all these benefits, right?
Yeah, yeah. I mean, with the fasting mimetic, it's a pretty easy one, right? Because no one on the whole is going to be experiencing a 36-hour fast, right?
Sure.
So for most folks, this is just something that they can incorporate into their daily routine to help them achieve something that they wouldn't ordinarily achieve or wouldn't even, think about achieving, right? We definitely want to make sure that everything that we're saying, all of our claims are backed up by science, that they're backed up by the clinical data. And we definitely don't want people to use it as an excuse to be unhealthy, right? So if it's
Mm.
like, oh, well, I was eating, nothing but salads, and then I started taking Mimeo and I was like, all right, great. Well, now I can just eat cheeseburgers and donuts and I'll be perfectly fine. That's not going to happen, right? We can't undo the good things that you're going to do for your body. But what we can say is that will make you healthier, essentially. Like if you are eating 3 burgers a day already and you start taking Mimeo, you're going to be better off for doing that.
Mm.
But, a healthy lifestyle is going to be the major thing that's going to be pushing you forward.
I like that, man. What's sort of the moonshot idea with like unlimited funding, whatever, a couple decades down the road? Where do you see Mimeo being?
Yeah, so with like unlimited funding, it's basically what I was describing before, where we're just really looking at all of these interesting regenerative states of the
Sure.
body, teasing out all of these interesting processes, finding all these new clinically derived health and longevity molecules, and putting them into these biomimetic synergistic formulations so that we can really allow people to harness the power of their own biology and put that on demand.
Yeah, for sure. Cool. Cool. I like that for sure. More on like the sort of broader picture of like the anti-aging thing. Like where do you see sort of this going in the long run? Like we're probably
Mm.
not gonna die. I think that's what I ask everyone that that
Yeah,
I talk about longevity. I ask them.
I think
I
that's
like their perspective.
a really interesting thing about longevity is that I think that there's a big misconception, especially in the mainstream world,
Mm,
about what longevity really means. Brian Johnson is like not super helpful to this, right? Like the slogan
right.
"Don't die" is kind of like everybody's the antithesis of what everybody wants it to be. I think that what longevity really is not immense lifespan extension just for the sake of it, right? The biggest thing that people fear, I think, when they think about getting older is this loss of functionality, this loss of health, this loss of quality of life over time. When I talk to people about like, wow, like wouldn't it be cool if we could live to 120? Usually what they tell me is like, oh man, like I don't even want to live to like 90. Like you'd just be so old, you'd be so frail, all of that stuff, right? So
Right.
what they're describing is what's called the health span lifespan gap. And what that means is health span is essentially the amount of time in your life that you do not have some kind of disease, right? That you don't have some kind of like major chronic illness that is going to be affecting your quality of life. And your lifespan is, of course, the amount of time that you actually live. So the worst case scenario for most people is that they have a lifespan of 100, but they only have a health span of 80. So there's that last like 20 years of their life where they're really slowing down, they're not in good health, like their quality of life is going away. That's the terrifying thing for most people. What I think longevity research is really about is making the health span, lifespan gap as small as possible. I think what we all want is really like, okay, cool, I'm 98 years old and I just finished a marathon. I got to have this huge meal of all my favorite foods and it was amazing. I went to sleep and I never woke up. Right? Like that's, I think, what longevity is all about, where we can get to the ends of our lives as healthy, as functional, as happy as possible.
Yeah, that sounds exciting. I like that. Audience mainly being like 20s, 30s on the show. What would you sort of say to them as far as, obviously, besides taking Mimeo, doing to get to that point? Like, do this now, or like, don't fuck this up, or whatever.
Yeah, for sure. I would definitely recommend intermittent fasting, even if you are taking Mimeo. That's how I use Mimeo now. So I'm on a 1 meal a day schedule. So
Okay.
I'll take Mimeo in the morning alongside some green tea. And that will really help to kind of carry me through the day with those appetite suppression effects, with those mood and cognition enhancement effects. And then I'll work out in the fasted state, mainly strength training, and then eat my big kind of reward meal at the end of the day to support muscle growth and those pro-growth pathways, but without over-indexing on them to the point where it might have a significant result on, pro-aging, right? So that's kind of how I am approaching things right now, that I'm still getting those benefits of fasting and supercharging them with Mimeo, making fasting easier that way. Then strength training is, I also think, really, really important. Strength training, balance training, flexibility training. One of the best ways or best markers that we know of right now to predict longevity is actually muscle mass at the age of 65. So going into age 65 with as much muscle mass and as much bone density as you can is really, really impactful for your lifespan overall, because one of the major things that the elderly have to deal with is sarcopenia, muscle wasting, bone loss, right? Frailty, breaks, falls, lack of exercise performance, and the day-to-day aches and pains that come along with getting older. So strength training, balance, flexibility training, all of that can really, really help, especially after 65, to help maintain quality of life, mobility, all of those things that we're all really concerned about losing.
For sure. Intermittent fasting, sweet spot being, so that's like 20 hours, 22 hours.
Yeah, I mean, what I do it is basically 1 meal a day, 24 hours, and that's because it's very beneficial from a cellular perspective, but it also just fits into my lifestyle, right? So that's another really important thing about anything that you're doing for longevity, is that you have to be able to sustain it long term. I used to do alternate day fasting when I was first getting really into the science, but there's this very hard element of social isolation that comes across with fasting like that, because you're not having meals with coworkers, you're not having dinner with friends, and if you are having dinner with friends, you're kind of like the weird guy who's just holding his glass of water and I'll just watch you eat, it's fine. So that kind of societal disconnect can be really challenging, especially because community and strong interpersonal relationships is also really important for longevity and quality of life long term. So I would say 1 meal a day is the sweet spot for me, because I can still have meals with friends, meals with family, at the end of the day. And on a typical work day, that's what you're going to be doing anyway, right? So you can kind of just get to focus on what you're doing all the work day, then have your big reward meal at the end of the day, where you can basically just eat whatever you want. So even though it seems from the outside very restrictive, it actually works really well from a lifestyle perspective, at least for me.
Thanks for listening to the Quinn podcast. If you enjoyed it, you can go to quinnpodcast.com to check out all of the previous episodes. quinnpodcast.com.